Hey there, this is Mr. Alexander, and I'm recording a video for Pre-AP Algebra 2 students at Stony Point High School for what we did in class on September the 12th and September the 15th. And the first thing we talked about were composite functions, which were our functions that are nested functions, functions within functions. And I want to show you a few examples here. I'm going to start with number 4. And we're supposed to find g of f of x. And I like to write that this way. G of f of x. Now the easiest way to do this is to start with the g of x, and everywhere you see an x, I just want you to write some parentheses. In this case, we just have one x, so I'm going to write one set of parentheses, and that plus 4. Inside that set of parentheses, I want you to write f of x. So it's 3x plus 2. See how I nested f of x within g of x. And then I just need to simplify this thing. So 3x plus 2 plus 4 is simply just plus 2 plus 4, which is 3x plus 6. So that's pretty simple. What you need to do now is plug in a negative 10. So g of f of negative 10 equals 3 times negative 10 plus 6. 3 times negative 10 is negative 30. Negative 30 plus 6 is negative 24. So that's not too bad. Let me show you another one. Let me show you number 5. The next one. Where again we're going to find g of h of x. So I like to write that like this. G of h of x. And you start with g, got your 4. Everywhere you see a t, put some parentheses, and I get a plus 4. Inside the parentheses, we're going to write h of x. So that's t squared, and use capital T, minus 1. All right? Now I'm going to simplify that. 4 times t squared is 4t squared. 4 times negative 1 is negative 4. And then I've got a plus 4. Well, what's nice about this is the negative 4 and the positive 4 cancel out, and I'm left with just 4t squared. So, if I want to know g of h of 4, that's g of h of 4. I'm going to take that 4t squared, and I'm going to plug in a 4. So 4 squared is 16. 16 times 4 is 64. And that's it. That's how you do composite functions. You're just plugging functions within other functions. It's pretty simple. The other thing we talked about in class are inverses. Now, inverses are just opposites. And what I want you to remember about inverses is that with inverses, you switch the x and y. And it's really this simple. So if you have a function or a set of coordinates like this, to find the inverse, all I want you to do is switch the x and the y. So negative 5, 7 becomes 7, negative 5. Negative 6, negative 8 becomes negative 8, negative 6. 1, negative 2 becomes negative 2, 1. And 10, 3 becomes 3, 10. And then you put your fancy brackets on there. That's a 3. So that's it. That's when you're given a set of coordinates, all you really need to do are switch the x and the y, and you're done. You've listed the inverse. It's a little bit more involved with these bottom ones, where we have to actually do it with a function. And it's a pretty simple process, though. Let's just take a look at number 4. And we're supposed to find an equation for the inverse for each of the following relations. Okay, so here's a relation. F of x equals negative 5x minus 7. Remember my rule. We're switching the x and the y. So the first thing I like to do is I like to switch f of x with a y. So y equals negative 5x minus 7. Just like that. Then you're going to switch them. X equals negative 5y minus 7. Now all we have to do is solve for y. So I'm going to add 7 to both sides. It's going to give me x plus 7 equals negative 5y. Still trying to get the y by itself? Divide by negative 5. So I'm going to have negative x plus 7 divided by 5. I just took the negative from the negative 5 and moved it out front. I'm allowed to do that. That's okay. Equals y. But you're not done yet. The last step is to write it in function notation. So you really need to do is write f negative 1x. This is a symbol for inverse. Equals negative x plus 7 over 5. And I moved that minus sign again. That negative could be on the bottom, it could be on the side, it could be on the top. It doesn't really matter where that negative is. This is the inverse. All right, I want to show you one more. I want to show you number 12 back here.
I'm here.
I was told that if you join marching band, to like go marching in the sun, it'll let you know.
On number 12, it's the same thing. Y equals x squared minus 4. And we just want to flip the x and the y. So we're going to have x equals y squared minus 4. And we need to solve for y. So add 4 to both sides. X plus 4 equals y squared. Still need to get y by itself. So the opposite of square is square root. Take the square root of x plus 4 equals y. That's it, right? Wrong. Whenever you take a square root, there's actually 2 solutions here. Don't forget your positive and negative. Y equals positive negative square root of x plus 4. It's very important. Whenever you take a square root, it's positive and negative. Do not forget that. Of course, the last step here is to write it in function notation. F negative 1 of x equals plus and minus x plus 4. This is the answer to number 12. I got time. I'm going to show you one more. Last one I want to show you is number 14 here. Show you number 14. Same process. Trying to find the inverse, switch the x and the y. So y equals x minus 6 squared. Switch the x and the y. X equals y minus 6 squared. All right. Now, since we got some parentheses here, the first thing we need to do is take the square root of both sides. Square root of x equals y minus 6. Don't forget, whenever you take a square root, it's positive and negative. Then to get to y by itself, you add 6 to both sides. So positive and negative square root of x plus 6 equals y. You're almost done. Last step. F negative 1 of x equals positive and negative square root of x plus 6. That is your inverse. So if you only remember one thing, remember to switch the x and the y, and then you'll be able to do inverses. All right, that's it. If you've been watching my videos, you think I'm doing a good job, tell me in the comments. If I need to do something different, tell me that in the comments too. If you don't care, don't leave any comments. Thank you for watching. We'll see you next time.